In this video, we will be finding out how to determine Planck's constant. Before we begin, let's get some context. What is Planck's constant? Planck's constant links the energy of a photon to its frequency. It's named after physicist Max Planck. The accepted value for Planck's constant is 6.626 times 10 to the minus 34 plus or minus 10 to the minus 40 joules per second. How did he come about this constant? The ultraviolet catastrophe came around by the end of the 19th century. Scientists were concerned about the spectrum of radiation that comes from a black body, which is a hypothetical perfect absorber and emitter of energy at all electromagnetic wavelengths. Classical theory assumed an infinite amount of energy was emitted at small wavelengths, which is in direct contradiction with the law of conservation of energy. Planck solved the ultraviolet catastrophe by saying the walls of a black body cavity contain oscillating electrons that emit and absorb radiation at all wavelengths. Through this, Planck showed that energy is quantized. Now that we understand the background, we can look at the experiment we used to determine Planck's constant. This is the apparatus we used in the experiment. We started off by soldering components, for example the phototransistor, to a strip board. This was a new skill attained by all of us, which would hopefully help us in the future. We attached this to a box with a light bulb inside, which represents a black body. We used this equipment to enable us to measure variables, such as the voltage and current. The calculation of further variables enabled us to draw graphs from which we deducted Planck's constant. You're probably wondering what was our result. We got a value of 6.4 times 10 to the minus 34 plus or minus 0.1 times 10 to the minus 34 joules per second. Our value falls under the accepted value for Planck's constant. Why is this, you ask? Well, for starters, we didn't use a perfect black body. In addition, the strip board had a minimal resistance, but this was very difficult to control. We could have improved the accuracy of our results by using a better black body, for example, a furnace. Today, Planck's constant is used to observe starlight and is very useful in the search for new exoplanets.
Because